Yeah, g'day everyone. This is Nick from Electric Wheels Australia, also known as Perth Electric Scooter Repairs in Perth, Western Australia. And this video is about how to test a generic controller box like this one, the JP brand, which is a 48 volt 25 amp, and you've got something similar to this, doesn't have to be exact, but similar to this, then you can check to see if it is faulty. Now, you don't need to open up the box to check if it's faulty. What you do need, of course, is the multimeter, but also be able to connect up your multimeter to the connector here that connects up to the battery. Of course, you have the battery disconnected in your scooter, but you disconnect this from your battery. And also you've got the three-phase wires here that go to your motor. Okay, now what you'll find is that in the previous video I show you how to actually check the condition of the Mosfet through, or your controller, through using a multimeter on these connectors here. I'm not going to show you it this time because you've just got to scroll through my videos. There's not that many of them at the moment. That shows you how to actually do that using a multimeter and what mode to put it in. But I will talk about the mode this time as well. Now, if you notice here, just move that out of the way. If you notice here, okay, there are, if you look at that Mosfet, and I'll explain a bit about Mosfets and why this is important, you'll find that there is meant to be a component in there. That's this one here. Was removed from there, and then you've got another 5 exact same Mosfets there. Now this one is not a Mosfet. It looks like it, but it's actually an LM317, which is a voltage regulator. So it takes in the battery voltage of 48 volts and then regulates it down to 12 volts. It's and with assistance of these capacitors to help keep it smooth, so it's a smooth DC. Okay, and what's also relevant are these 3 little capacitors here. Okay, they're all electrolytic capacitors. Now that means basically you've got to orientate, see there, you've got a negative on there, you've got to orientate it relative to the circuit requirements. Positive and negative on the board. Now, when you connect up your charger to your scooter, you'll get that sound when you get a little spark, and that's because of these capacitors. What happens is that this connector here, which connects up to your battery, but also to your charger via an additional cable, so they're interconnected. And what happens is it appears to be short across here initially because a sudden inrush of current. These little fellas here tend to appear to be short until after a few seconds. Then when they get enough charge, then it doesn't appear to be short across there. All right, a good one of these, and you put a multimeter across there. Okay, we'll say in this mode, see if you can see that. All right, it's continuance. All right, and it tells you whether something's short or not. Continuity. All right, and if you notice that on multimeters it should beep. All right, that means there's a short. If you notice there, it goes down to, eventually down to 0. Now that will do the same thing here when you initially hook up your multimeter, okay, to continuity mode. You hook it up there and you'll get that beep, but then after a few seconds it'll disappear as that climbs up. You'll see it climbing up. Now the OL just means outside of the limits of the multimeter readings. It doesn't mean overload, okay? Don't think that at all. Now going back to this fella here, now what you'll find is that here are the blue, the yellow and the green, okay? The blue, yellow and green that go to your motor, all right? and they are connected up to the Mosfets that are sitting here. Each one of these cables gets two or a pair of Mosfets each. So those two there are connected up to blue, those two there to yellow, and then finally those two to the green. Okay, so remember that's a regulator. It's got nothing to do with the output to the motor. Now, what I found initially was that this one was faulty, but I didn't check to see if this one was faulty. And in previous videos, I was talking about this only, and then I checked the other side and did a comparison between them all, because when you look at it, there's three pins there, another three there, because there's three pins, right? Another three, another three, another three, another three. Ignore that. That's the regulator. Now, as pairs like that, they all should appear identical when you're testing it with a multimeter. Okay, so what I did was I checked this one and go, oh yeah, that's faulty. But in actual fact, I didn't check this one properly, and it is actually faulty, this particular one. So the blue phase wire is gone. And what does happen in that case often is that when you try and rotate the motor, it feels like it's braking, all right? You know, like electric braking, so that it is stubborn. It's being very stubborn in getting you to turn the wheel. Now, one thing, if you're playing around with these, is that you've got to be aware of the way they're connected to, the MOSFETs are connected to the heatsink, okay? Now, if you notice, there's this yellow tape stuff. It's a specialized tape, and for the life of me I cannot remember the name of it. If I in due course I'll mention it down below. And it is an insulator, but also in terms of electrical insulator, but it's also good at thermal transfer of heat. Not great, but good. And also there's a little bit of heatsink compound, all right, which people use on their computer CPUs. Okay, now if you also notice, there's a washer here. Okay, I'm not looking at the screen, so I don't know if you can see clearly, but there's a washer there and there and there and so forth. This is the fella here, and if you notice, okay, it's not a normal washer. It's also got that little piece there, and the reason why is because the actual MOSFET body has got to be isolated, okay, from this fella here, all right, so that when you screw in, the screw's not touching the back pane of the MOSFET and not touching the heatsink. Okay, it mustn't do that. It must be isolated. So you must ensure you've got that little washer in place when you go to rebuild it. Now, we won't worry about the one that is stuffed right now, but what I'm going to do is show you how to test a MOSFET. Now, the MOSFETs are transistors. They are associated with the diodes as well in regards to how you test them. So we're going to use the multimeter in diode mode. One more. And what you'll see here, it looks like an arrow with a little plus in front of it. Okay, that is diode mode, and we've got to test MOSFETs and diodes, transistors as well. Well, this is a transistor, but transistors, you've got to test them in diode mode. Now, if you notice there, it's got 0.0 L at the moment, but also it's got a V there, okay? That means there's voltage, and that voltage is coming out of the probes, which I've got here, okay? Now, if I touch them together, you don't get a beep, and it goes to 0.00 V. Out of here is 1.5 volts. It's designed, when you're doing a diode mode, to put a voltage across a diode or a transistor, okay? Now, the purpose of that is that, like in this case, you're testing the component outside of a circuit, and to drive it in some way or another, you've got to put a little bit of voltage across it, All right. So if we look at the theoretical diagram or internal circuitry, what we've got here in the case of the Mosfet. Now, if you want to know what Mosfet stands for, it means metal oxide semiconductor field effect transistor. So what that basically means is that here the G is the gate, the D the drain, and the S is the source. In other words, you hook up your battery, your positive to the source, and the drain is the negative side, but the gate is what controls the flow of current, okay, through there. And that's where you would be connecting up to your motor, okay. Now, internally, this looks like the arrow, you know, the arrow with the plus sign as on the multimeter, but in actual fact, MOSFETs don't have that. They don't actually have a diode internally. That's just showing you that expect electrically it'll look like a diode internally. So when you hook up these two probes to it, okay, it'll act in a way and show on the screen that it's acting as a diode. Now what happens is what they say forward bias, you make that positive and negative. Forward bias, there's a little barrier between this side and this side, and it gets squeezed. When you forward bias, it means basically there's a barrier which is narrowed, and that gives a chance for electrons to go through, okay. When you have them around the other way, with positive and negative, then what happens is that this barrier widens out, okay, and it stops the electrons going through, okay. Now, there are different MOSFETs. There's got a little arrow pointing in towards the gate, and then you've got ones pointing out from the gate. All right, that is relevant to how everything works here as well. We're only concerned about this particular setup. Majority of MOSFETs have the arrow pointing towards the gate. Now, what does the gate do? What you do is you feed a signal to the gate, okay? It might be a pulse, a voltage like that, a pulse from 0 to 48 volts, okay? Now, and then it drops back down to 0 again. Now, when you do that, when you feed a voltage across the gate, what it does is it creates an electric field, all right, electrical field. And that electric field interacts with the electrons going through the MOSFET to the point where it can constrict the flow or open up the flow of the electrons. Now, I'm not going to get into detail about that, but imagine a pipe, okay, a fairly flexible pipe, and you put more pressure, all right, on the pipe, you're squeezing it, and that means less water is going to go through. That's what happens here, okay. Now, what I'm going to do is I'm going to check across here and see if I'm going to get a forward bias or reverse bias. In a forward bias situation, because this is pumping out 1.5 volts, in actual fact, across here, I expect to see around about 0.5 volts, okay? Now, with silicon, it's about 0.6, but that's fine, 0.607. But if it's 0.4 to 0.7, say, volts, right, half a volt, then it should be fine. So what I'm going to do is I'm going to connect up like so, okay, and check to see. So on this diagram here, you see this picture here, it's got the D, in the center pin and on the back pane as well. They're interconnected to each other. It's the same, all right? And then you got your source and then you got your gate. What we're going to do is we're going to put the black probe, all right, the negative probe, onto the drain, and we're going to put the positive probe onto the source, like so, across there, which is, if you see there, are those two. Now, what you'll see here on the multimeter is reading 0.000 volts. That means there's no voltage at all visible. If I swap them over, I get the same, okay? Now, if we look at one that is brand new and working and fine, and we put the black and negative probe onto the drain, and then a positive one onto the source, we get 0.457. All right, that's fine. The additional decimal places don't really matter. It's effectively 0.5 or half a volt. Okay, but on here we didn't get anything, and the reason being is because there's no barrier in here. It's just a straight short going through. It's buggered. Okay, it's stuffed. So either way, it doesn't matter what happens. So if I look at the good one and I swap them over, okay, it's outside of the limit, which we expected, because what happens in that case, the little barrier inside is expanded, all right, widened, and it's stopping the electrons going through. So even though I've put a voltage or potential difference, all right, that's the voltage, potential difference between those 2 points, it's not enough to drive the electrons through past the barrier, okay? But as I said, when there's a short, all right, there's no barrier there, and that effectively means that that diode's stuffed. That Mosfet is stuffed. It's gone. Now, what I did was, I'll just move these out of the way, okay? There's the, I'll just have to spin it that way so it tilts towards us. Now, there's the 3 holes that one came out of, the one that's destroyed itself, okay? And here is its paired as well, okay? It's identical. Now, if I have a look, if I just remove that and look at how that's positioned, like so, that tells me that on the end there is the source. Whoops, there's the source, and that's the drain. We're not worried about the gate, okay? Not worried about the gate at all. Now, what I'll do is, on the good one, I'll show you what happens when I put it on a good one. So there's your drain, and there's your source. Voila, 0.442. Let's do the same to this one, okay? And so forth. Let's just hope that the rest of them are good. I don't really want to change the amount, and of course that's the regulator. We're not worried about that. So they're all proven to be good. All right, let's check this one, the paired with the burnt out one. 0.00 volts. It should read 0.4 or half a volt. It's not. Okay, so I'll swap them around. Same. That one has blown as well. So the 2 MOSFETs associated with the blue wire has failed. Okay, so what can we do about that? Well, it's simple. We just replace it. Okay, but when you do replace it, make sure that you put a bit of heatsink compound on it. All right, where do you find that? You can get little tubes of it in electronics store, on eBay or AliExpress or something like that. It doesn't have to be anything fancy. You can if you want it, but not the liquid metal stuff. No, don't use that. Just use the normal white pasty looking stuff and you'll be fine. So when you do feed it through, okay, like so, you align it to the hole. Whee! Align it to the hole, like so, okay, and you put your screw in, like so. It says like so, okay, and get myself a screwdriver, and then, oh, hang on a second, I'm getting there, it's running away. Get that blue wire out of the way, okay, and make sure, as I said, you put heatsink compound on it. But this is what I'm just showing you, what you've got to be careful about. And you've got the washer, and you put it in there like so, align it, and oop, there she goes. She wants to go in. And you screw it in place, okay? I mean, if you forget to put compound on it, and you put it all together again, you screw it back together again, well, it just means that there's a little bit on there, but it just means it's likely to get a little bit hotter than normal and probably fail a lot sooner. And it just means you have to get put a new one in. And then you've got your pins underneath. You solder them in. Okay, make sure the solder does not run across from one pin to another. All right, that it's clean between them. Okay, and then you snip off the leads as you need to. Now this particular, the reason why I'm showing you this one, this particular controller, is because the brand, this is in Western Australia, is a brand called Electro. It's ELEKTRO, and this is on a Super 8 scooter, a real little scooter, single motor, and they asked $200 for this controller. And you can get basically the same or similar controller, 48 volts, 25 amps, with basically the same cables as what's here, and I'll explain in a minute what the difference is. But you'll find that you can buy these on AliExpress for approximately $50. Now be aware these prices are Australian dollars. So if you're talking about American dollars, it's not 200, but it'd be about 140, 150, something like that, dollars US. And I think that is, well, put it this way, I wouldn't charge $200 for something that I know that I can get hold of for 50. So to me, for the customer, fixing up his Electro is controller is the best bet. It's outside of warranty, so there's no concerns about warranty. I could turn around and order one of these in, but by the time I do, it's 2 weeks down the track. I want to get this done, but also it gave me an opportunity to show you how to check a Mosfet inside a controller. Okay, that's all I can tell you about. Just to quickly, this is a peachy color, and there's another peachy color, and they are interconnected on the board. Okay, whilst the JP you find, or I've found so far, the cable just runs down and loops back up to this one, but it's still fed to the 12 volts. Okay, or whatever voltage that is. Yeah, 12 volts. I know that's 12 volts because you see here that one there is to that connector there, 12 volt connector, but you notice that the apricot colors are also soldered to it as well, so they're all the same voltage. They just do that so that it's easier to set up inside the scooter. That's all I can tell you for now. If there are any questions, please don't hesitate to ask. I don't mind doing another video if need be on this, but certainly be aware that you can buy these components, but you may have to buy about 5 of the little buggers. So it's only a couple of dollars. It won't hurt your budget in theory. And I'll leave it at that. Thanks very much for your time. Bye for now.